Out. We just want to let you know we're going to wait just a few more minutes so we can allow all the students who are coming out of their 3 o'clock classes to get here. So 5 minutes. Thank you. Well, that is 5 minutes, so we are going to go ahead and get started. Good afternoon, everyone, and thank you for joining us to kick off the 2021 WSU SEL Collaboration Week. My name is Albert James, and I will be a co-moderator for tonight's discussion. To tell you a little bit about myself, I'm currently a junior at the Edward R. Murrow College of Communication, majoring in broadcast news with an emphasis in broadcast production. After WSU, I aim to become a television news reporter, telling people's stories and bringing vital information to the masses.
Hello, is this working?
Yeah.
But then you don't. Well, I guess I can continue as we figure out the microphone difficulties. But hello, I am Cheryl Aarnio. I am also co-moderating this interview. I am a WSU senior studying multimedia journalism, and I have a supplemental major in French for the professions. I want to pursue a career as an editor, so in doing that, I actually was hired at SEL as an editor intern in May, and I was recently hired as a marketing associate editor. So now, let's meet our guests. Dr. Edmund O. Schweitzer, Dr. Edmund O. Schweitzer III, I should say, President and Chief Technology Officer of Schweitzer Engineering Laboratories, is recognized as a pioneer in digital power protection. He is a fellow of the Institute of Electrical and Electronics Engineers and a member of the National Academy of Engineering. Dr. Schweitzer has received numerous awards from universities and industry associations, including 4 honorary doctorates and the 2012 Medal in Power Engineering, which is the highest award given out by the IEEE. In 2019, Dr. Schweitzer was inducted into the National Inventors Hall of Fame for his invention of the first digital protective relay. He's written dozens of technical papers and holds more than 200 patents. Dr. Schweitzer received his bachelor's and master's degrees in electrical engineering from Purdue University and his doctorate from WSU. In 1982, he founded SEL to develop and manufacture digital protective relays and related products and services for electrical power systems.
Also joining us is Dave Whitehead, Chief Executive Officer at SEL, who oversees global operations in research and development, sales and customer service, engineering services, manufacturing, human resources, marketing and communications, and business. He is responsible for translating the company's executive vision into effective corporate strategies that prioritize quality, innovation, service, and growth. Mr. Whitehead serves on the board of directors for both SEL and Veracity Industrial Networks, is a senior member of IEEE, and is the past chair of the IEEE Power and Energy Society Substation C6 Committee. He is a registered professional engineer, credited with over 73 patents, and holds a Bachelor of Science degree, a Master of Science, and an honorary doctorate in electrical engineering. He has been with SEL for over 25 years.
SEL partners with customers around the world to ensure the safe, reliable, and economical delivery of electric power. The company designs, manufactures, and supports a complete line of products and services ranging from generator and transmission protection to distribution, automation, and control systems. Our first question today goes to Dr. Schweitzer. What brought you to WSU to get your doctorate, and why was Pullman the right place to launch SEL?
Man, you're starting with ancient history. So my first job out of school is I worked for the Defense Department, and after 5 years of doing that, I really wanted to do something much more related to energy and electric power in particular. So I started looking around where to go to grad school, and was living in California that year and looked at various schools. At Washington State University had maintained its expertise in electric power systems. Professors Sabia, Mosier, Baker, and others, Professor Siemens. And I said, wow, that's where I want to go. And I got to tell you, I drove up here in spring one year to just have a look around, and it was so beautiful here that I not only liked the people I met with, but also I just fell in love with the Palouse.
That's a wonderful answer.
So I get an A?
Yes. I think you always get an A, you know?
All right. Mr. Whitehead, you started at SEL in 1994 as an engineer. How and why did you move up through the company to get to the position of CEO?
Well, please call me Dave. You know, I never, when I graduated from WSU in 1989 as an electrical engineer, all I wanted to do was build hardware at the time. You know, computer-based products that would do things. And I never had aspirations to be a CEO of a company. And then all of a sudden you look back, 27 years later, I've been with SEL, and I'm the CEO. And it wasn't a direct career path. You know, I woke up every morning, how do I become CEO? How do I become CEO? Rather, I was building hardware, and I really wanted to know how the software worked inside our product. So I learned about the software, and then the mechanical engineering, and then the manufacturing side. And then, well, you build something, you got to get paid for it. So there's the business side of it. So all of these things kind of just happened one after the other. It's like, how does that work? How does that work? How does that work? And then all of a sudden you have a whole bunch of skill sets that you can put together that can help you try to be the CEO of a billion-dollar company that has 5,300 people around the world. It's what wasn't a plan, but it all seemed to work out pretty well.
So your curiosity just helped the chips to fall right into place.
That's exactly it. It's this curiosity of how does that work, or how do people do their job, and figuring that out.
Dave would ask me, how's this work? I said, heck, I don't know. Let's go figure it out together. So we've had a lot of fun working together over the years.
All right, and yeah, my next question is to you, Ed. So what prompted you to launch your own company instead of, joining a company that was manufacturing electrical engineering components?
Well, there's a whole bunch of reasons. One is I did become a professor here, and I loved teaching. My favorite thing was to do the labs, especially the rotating machinery labs. And electronics labs are okay too, but I just loved that hands-on work, side by side with students. It was just a kick in the pants. And I like to say that the reason I had to start SEL is pretty soon WSU figured out I couldn't pass the tests I was giving, so I had to go do something. And really the dream was, gosh, it would be so cool to be able to, kind of like Dave was talking about, to be able to see some of these ideas that I've had that actually turn into products, and then to see people buying them and benefiting from them. So I started in college in 1965. So in 1965, they rounded up all of us kids at Purdue, and they put us in a big room, Engineering 100. Yeah, first day of school, the professor says, take out a sheet of paper. You never want to hear that, right? And so we took out a sheet of paper and said, now write down why you want to be an engineer. So I said, well, I want to be able to take science, math, technology, and somehow put them together and hopefully do things that somehow make the world a little bit better place. And so that's what really the motivation was. And my dream has always been to solve more problems than I create. So I'm still working on that.
All right, so now this is a question for both of you.
Okay.
So both of you have been at SEL for a number of years, over 2 decades at least. And there have probably been some mistakes you've made along the way. So has there been a notable failure that you've grown from?
I never did anything wrong. Did you, Dave?
I wish I could say the same thing. It's, we usually have we do have a saying at SEL, like, how hard can it be?
And then we always find out.
Everything is a lot harder than we thought it was going to be.
You know the easy, hard, easy theory, right? You start on a project, or I'm going to sign up for that course, or whatever it is. So, this will be easy. So then you get into it, and the easy turns into hard. right? Oh my gosh, why did we ever say we were going to do this and promise that to the customer? Oh, how am I going to get through this course? The midterms coming, oh my God, struggle, struggle, struggle. And then finally at the end, when everything works, then it's easy. And you look back at the project and say, oh, that was easy, what's next? So the easy, hard, easy. So I think that's the thing. And in that hard part in there, of course there's mistakes. Well, that didn't quite work out the way we wanted. What are we going to do? And the trick to all this is to try not to invest too much in the mistake. Either personally, to, what's that joke? That to err is human, to forgive is not company policy. That's an awful joke, where the beatings will continue until attitudes improve. That the only person who doesn't make a mistake someday is the person, and at any time, is somebody who hasn't tried anything. And that we have to be patient with that and actually reward it. Not everything is going to work. And gosh, learn from our failed experiments. Edison talked about that. I don't need to repeat what he said, but you all know what it was. And a great lesson. And our parents taught us that, right? If at first you don't succeed, try again. And then try again after that.
Yeah, I'd really echo what Ed said. I always think of the Edison quote, right? What is it? 99 ways how not to build a light bulb.
Yeah, they were working on filaments. They tried everything. They even tried a red whisker from one of the lab tech's beards to see if they could make that work. It didn't. And finally what they did is they used a carbonized thread, essentially, and later tungsten. So they went through something like 500 different filaments that would light up and then burn out, light up then burn out. And one of the lab workers said, Mr. Edison, we've tried 500 things and we've gotten nowhere. And Edison looked at the guy and said, you know what? Those are 500 things that we're not going to try again. We've gotten somewhere.
Yeah, I learn a lot from things that don't work. And I've learned a lot. Let me trust me on that. But that's what I think you really remember. It's if everything goes just like planned, it's like, well, that was great. I don't think you learned quite as much. And I love that Edison quote, right? Let's try things, different things. Eventually, you got to get something that works. Don't get me wrong, but you learn so much from things that don't work quite the way you thought it was. So that's that inspiration. It's like I thought it was going to work this way, and you figure out it works quite a little bit different, maybe.
How about in your lab courses? The professor says, okay, you're going to go do something in chem lab or physics lab or electronics, whatever it is. And you set up the experiment and it doesn't work. And you say, nuts, you did all your pre-calcs before doing it in the lab and it just didn't work. What a learning experience that is. So we're all used to that. And it's and that whole thing, it's a really innate part of what the good Lord made every one of us, that part of the self, that curiosity, that, hey, I wonder if this will work. And obviously the fun of it all is to figure out how to find out with as efficiently and safely and cleanly as possible.
So it's about learning from failure and not getting discouraged by the failure.
No, get motivated by it. Is that right, Dave?
I do.
We've motivated each other a lot over the years.
maybe more than we should have. I can remember sitting over in Carpenter. I think that's where it was, or Dana, one of downstairs, and this is one of those things. I don't remember all the great things we did in labs, but I remember a failure once. Is I built this great low-pass filter. It rolled off at, 20 kilohertz or something like that on paper. Anyway, I went and built it, put it in the lab, and put the O-scope on it. I made the most awesome oscillator you could ever imagine, right? And that was certainly not my design. That's when I learned about how you had to decouple the power supplies from the rest of your circuit. That's something I'll take away, right? Not a success at the beginning, but one of those little failures. I was like, oh, I'll never forget that.
That's a great thing about Washington State University is that this university still believes in hands-on laboratories, and you need to learn with your hands and your minds. And that's something that WSU has maintained, thank goodness.
If either of you could go back and talk to your 20-year-old selves, would you encourage them to do anything differently? And do you have any advice for the students around that age who are watching here today?
You want to go first? All right, I will. My piece of advice is, I use this on myself still. It is slow down, right? This.
Especially when you're eating, Dave.
Yeah. Well, I didn't say I'm perfect yet, but I still have that problem. But slow down. Think about what you're going to do. Step back maybe a little bit. Think about the big picture, and you're going to save yourself so much time in the long run. Even with my golf swing, I got to remind myself, slow down. It works everywhere. Slow down just a little bit, and things will work out a lot better, a lot quicker.
Well, my wife would argue about there being a 20-year-old in me. I think she'd say it's 14 or something. So, but I guess looking back, it's to be. I wish it's woulda, coulda, shoulda. I wish I could have even been more curious. That Dave says slow it down, and there's so much truth in that too. Is that pretty soon you can get so busy you don't know you're alive. And one of the things that was hard for me to learn is, every one of us is creative, and it's inside each and every one of us. And I like to say God made every one of us different for a reason. And when that comes out is when you find your way to sit down in a chair, be quiet, think, put your phone on silent and put it in another room, decouple from all of that stuff. And just like now, when we're quiet for a second, you start to hear the ambience and just kind of let whatever comes to mind come to mind. And, so it's a sort of a meditative thing that I'm sure many of you are very, very good at. I wasn't, and still am. It's so easy. And then get up in the morning, you're in a great big hurry, you got to do this, got to do this, got to do this. Maybe you're one of these people who likes to check things off the list all day. And at some point it's important just to, as Dave said, slow it down. Or for me, it's just to be able to sit in a nice chair like this, maybe with a cup of coffee, no newspaper, no books, just be for a while and think.
Some very good points about living in the moment and taking it all in. We know that SEL manufactures products to protect, control, and automate power systems, but can you elaborate on, what really does SEL do?
Well, the way we got started was in power transmission lines. And you see them all over the place, the tall poles that carry the three-phase conductors. These are moving electric power at the speed of light at the flick of a switch. And it's just tremendous, tremendous. And it's so controllable compared to a pipeline or freight cars. And we're moving energy at the speed of light, 186,000 miles a second, 11 inches a nanosecond. And only we get to do that, we in the electric power industry. So what our products do is they monitor that system, and if something goes wrong, like lightning strikes a power line, you got to turn it off, and you turn it right back on. But we figure out that this is the line to take out, not that one, and then trip the circuit breakers at the two ends of the line, isolate the section in trouble, and then after a few milliseconds reclose it. Have you ever noticed that? A thunderstorm rolls through and you see your lights go off and come right back on? Yeah? Somebody said yeah. Or sometimes they go off and stay off. It just depends if the fault is permanent or not. And that's our equipment doing that. And since we're protecting energy moving at the speed of light, we try to do this fast. 20 milliseconds used to be fast. And that's pretty much where our competitors are. In SEL, I'm proud to say, is down around 1 to 2 milliseconds. We can do it. That's like moving from a car to a jet in our business. And the technology for doing that came from a group of us. I was the only American in the team. Can you imagine that? I was the only U.S. guy, a Mexican, sounds like a joke, Polish fella, Serbian, India, what'd I miss?
South Africa.
South Africa, 6 different countries. Isn't that fun? And that's right here in Pullman, Washington, 99163, being able to do this. So we started with the transmission lines, now we do distribution feeders and generators and transformers, and we integrate photovoltaics and wind farms, and gosh, some countries where the lights would go out once a week or once a month, now it never happens. It's made tremendous changes, and that's what we do right over here, a mile away from where you go to school.
But unlike Apple, where they just design stuff in Cupertino, we design stuff here in Pullman, and then we build the stuff here in Pullman and ship it around the world.
So your friends and neighbors in Pullman and Lewiston, that's what we're doing. Here's the verbs: invent, design, manufacture, sell, support, teach. Whatever it takes to make electric power safer, more reliable, more economical. Products are in 165 countries around the world today. Today, right from the plant over here, I'll bet we shipped to 35 different countries. That's sort of an average every day.
Yeah, I bet we're hiring from every college on the university, except for maybe ag, or I don't know, maybe we would hire people from that school too. That's how broad our skill sets are at SEL, from finance to marketing to communications. Congratulations for joining SEL. Thank you. To everything. It's amazing. We love to be vertically integrated. It's probably crazy these days. Maybe it's not anymore. But man, what a way to run a business where you can control all the aspects of whatever it is you're producing, inventing, or designing, and shipping, selling, supporting.
We just have a ball. That's what our business, that's what we do for our industry. And in order to do, we got to know everything: electronics, digital signal processing, all aspects of electric power systems, power supplies, computer systems, the enclosures, all the testing standards and so forth. And now over in Moscow, Idaho, we got a 200,000 square foot hole in the ground over there that's a building going up where we're going to be making our own printed circuit boards. So right now, our guys design the circuits, our drafters then turn it into the board artwork, and we've been sending them out. And now this is about a $60 million project of all employee owners' money. We don't go to the government and ask them for any money. This is our opportunity to serve. So we have so much fun in all these different aspects. In supporting all of this, my goodness, we have sales, marketing. That's what you do, right?
Yes, I'm in marketing.
There you go. And we do, video recording. We do it, you name it, we do it.
We have a studio in our basement. It's pretty cool too. You should come over and see it.
I call it Studio 1A, and it'll be better than 2B or something, right? And we have our own medical clinic. We have a doctor and a bunch of nurses and nurse practitioners, and man, has that been a lot of fun. And it's this whole idea of being able to keep learning and attracting, trying new things. I'm 73 years old, and I still get excited every morning when I get up and think about what I'm going to do in the morning.
Thank you. That was a great explanation. So,
that's the first time anybody said that.
So SEL hires a lot of interns. What do interns bring to the company?
Yeah, I know what you want to say.
This is so near and dear to my heart. We have a huge intern program. It's 250 interns. I think right now we have a total of 61 positions open. 31 of those are here in Pullman, Washington. And what do the interns do? Well, you could answer it better than I am, because that's what you were doing before you decided to stay on as a full-time employee, which we're very grateful for. So the fun thing about being an intern is you get to see different parts of the company and experience it. You get paid while you're going to school, which always helps. And we ask our interns to work right alongside everybody else in a real flat, egalitarian way. This is not about like managers and workers, not in our company. We're flat as a pancake, and I like to keep it that way. So I hope you had that kind of an experience as an intern. And guess what? Dave and I like to make a joke about it. And if the problem is a real tough problem and nobody knows what to do with it, what do, Dave?
So we give it to an intern because they don't know it's too hard to solve.
Nobody told him or her it's too hard. That's right.
My daughter was interning for us this summer, and I was sitting down eating dinner with her one night. Hey, Brookie, what'd you do at work today? And she showed me a circuit board that she designed, right? An intern's designing a circuit board that's going into one of our test fixtures, and I thought, man, that's really cool. So what do interns bring? This curiosity, and what I like is that we provide this great opportunity for them to explore that curiosity. They're going to get some really good problems to solve at SEL, not a can problem or have them sweep the floor or something like that. They're going to be doing real engineering work or real finance work or real manufacturing work. It's they're part of the team.
And what's kind of fun about it too is when you go over there and spend whatever it is, your afternoon or your summer, however your schedule's working out, or both, working on something, then something comes to mind and dawns on you from one of your classes. Oh, so that's how it works. Then you can ask engineers or finance guys, whoever you're working with, hey, I was learning about this and I'm seeing this, is how do these relate? It makes it come alive, like you can see it, feel it, teach it, taste it, touch it.
It's great to hear that your interns are really an integral part of your company. SEL is 100% employee owned. So what does that look like, and how does that impact the work that you do?
Me? All right. I've been an employee owner since, right when I started. That's when 1994 is when Ed was nice enough to sell part of the company to the employee owners. We eventually became a completely employee owned in 2006. Am I doing that right? Somewhere around there. Somebody help me out, fact check me on that. But at this point, we're 100% employee owned. And here's somebody that has this opportunity to take advantage of this what they refer to as the ESOP. It is every day I go to work, I'm affecting what the stock value is. And it's my retirement plan, what it's going to end up being. It's unlike I could take, invest in Apple or somebody else and hope Tim Cook comes up with a good job. But it's sort of a derivative away from my retirement, how my money is going to grow. So everybody's showing up every single day, doing a good job, inventing new things, serving a customer, making a sell, whatever it might be, directly impacts the fortune of the company and therefore all the employee owners. We're one big team. It's shared equally. The way that the ESOP is distributed, it's a marvelous way to run a company where everybody has a real stake in the game.
And I mentioned earlier that I like this feeling of egalitarianism, and that's part of it. It's the difference between renting your job and owning your job, and taking such ownership for real. It's not just, I really own what I'm doing. That can be a subjective thing, but this is both subjective and objective. It's a big deal.
So being employee-owned, 100% employee-owned, is a draw to SEL, and it's something that SEL prides itself on. And SEL also prides itself on its values, like quality and integrity. So how have these values shaped the company?
They define it. we have a little book. You have a copy of it, right? The Principles of Operation. So the dean of your med school, Dr. John Tom Kowiak, I invited him down a few years ago to talk to us about leadership, and he surprised me. He took out a copy of our Principles of Operation and held it up, and he said, "Hey guys, this is your secret playbook." And these values, the 9 of them, community is one of them. Think how important that was during COVID. So these values really define, customer service, the focus on the client, creativity, quality. I don't know what else I missed right now, but they define what's important to us. And hey, one of the things that you've probably noticed it is when folks join, we have an opportunity at our Friday lunch meeting to ask, hey, why'd you want to join SEL? And the most common answer is because I appreciate the values of the company. So it's that important. And we stick with them. We stick with them. They're important to all of us.
Continuing on that note about company culture, how do you promote diversity and inclusivity at SEL, especially considering that you have over 100 offices worldwide?
Yep. Well, I think we actually do a lot. We're very active in various programs. Our leadership is made up of, I don't know, we must be a third of us are female when we talk about diversity and inclusion. There's activities we've been doing out at Purdue. There's other scholarships we've been investing in. Ed and Babe, in particular, have set up some special scholarships to help out folks. So when we look at how we go about integrating and hiring throughout our communities, it's just it goes back to a part of our culture, part of the way that we do business. So I wouldn't say that, last year this light bulb went on that said, hey, we should be doing this. No. You go talk about the principle of operation, that really guides the way we are inclusive and bringing folks in and looking at diverse thought, if you will. That's been from day one.
You take that word diverse or diversity, you hear it all the time, never quite sure what it means. I know what it means in an engineering sense with diversity communications and so forth. But in a cultural sense, that how are you, the only way that you're really going to get the best answers to the challenges that society faces is with a diverse perspective, and that means you need a lot of different eyeballs and brains seeing it and working on it. So the dumbest thing you could ever do in business or in life is to the sort of the opposite of diversity would be, say, exclusion or singularity. So if you think about it, how dumb would it be to say, we're only going to hire boys or girls? Either way, you just throw out half of the population. What are you going to miss in life with that? Or when it comes to any other subset based on any, race, religion, nationality. Come on, look at all the different perspectives that we all bring to one another. I give that example of the traveling wave technology, where there's a team of 6 of us who spoke natively 6 different languages, 6 different colors of skin, 6 different nationalities, and 6 different, really different personalities. We were all so different, it's amazing we got anything done, And that's a beautiful, beautiful thing. Diversity is truly a recognition of this grace of God having made us all different for a reason. It's a fundamental, important thing.
And so community is a big part of SEL's operations and its mission. How does SEL give back to the Palouse community?
I think one great way is that lots of our friends and neighbors in the internship programs and, that as a community, we're experiencing free enterprise, the creativity and the innovation and the work all together. It is a community binding thing, whether we talk about the Pullman-Moscow community or the electric power community or the cybersecurity community, or all these various communities, I guess, that we operate in. And a more recent one is over the past year and a half, we've all had to deal with this virus that none of us wanted. And it came from outside the United States, and we have to face it as a society. And that unites us as a community in the fight for that. And thanks to the genius of the researchers at Pfizer and Moderna and so forth, that folks developed these vaccines. And what SEL has done is we operated, I think, about 20 clinics, shot clinics. So we operated them. They were supported by our medical team, by also the folks from Palouse Medical, Dr. Simpson's doc shop, Pullman Hospital, WSU, many organizations, medical professionals were given shots. And we gave over, I don't know, I forgot the number, 15,000, could it be? 15,000 pokes. Who got poked at SEL? Anybody? Raise your hands. That's about, a sizable percentage of us here. And that feeling of community gives back. That at the beginning of this, especially for people, elderly, I don't like to call myself that way. I'm pretty immature, but are generally more vulnerable. The feeling of getting the shot was a feeling of elation, of elevation, of freedom, and that subjective part of being part of a community and being able to offer that and experience that together, to see everybody coming together. People I hadn't seen in some 10, 20, 30 years, people I'd never met before, and all of us coming together like never before, uniting Pullman, Washington around this common challenge.
Well, I remember
heartwarming.
We were sitting in the boardroom one day, and this is right when shots were going to become available, and the question was, how do you distribute the shots in an efficient manner? Because I remember the Coliseum was an idea, the first place, but as Ed mentioned, there was the elderly people, they're going to be in wheelchairs, maybe not the fastest walkers, the weather's probably not going to be very, very nice, and we were saying, well, man, we can't have big events in our event center. Why don't we open up that place to the community and just, we're very good at building assembly lines, right? And turning the event center into one of our manufacturing facilities. And I forgot the first day that the clinic was held there, I forgot how many shots were done. Maybe one every 30 minutes, or you had to be there for 30 minutes, maybe a little bit longer.
Right at 30.
And then I think by the end of it, it was like 22 minutes. I mean, we had stopwatches. That's how we love to measure stuff.
And what we did to measure them is we had some of our security guys track when somebody pulled into the parking lot. So as soon as they got to a parking place, that's when they started the timer. And when they got back in their car, and as soon as the car started to move, that's when we stopped it. We got down to 22, 23 minutes. And don't forget, 15 minutes was the amount of time you were at least supposed to sit there and twiddle your thumbs to make sure you weren't going to get dizzy or something. So we had more fun with that. We could have used your help. We made some videos and wrote some procedures up that we shared with others. A friend of mine who runs Catholic Charities up in Spokane came down and picked up a bunch of ideas and took back. We had a ball. you know, it's such a serious thing, but so heartwarming that, my goodness, maybe we ought to have a COVID party next year to celebrate, get people back over there where they had that feeling of elation. Who shared that kind of a feeling when they got their shots, that feeling of elation and relief and jubilance? Jubilation, that's the word I want. So.
And that's wonderful that SEL was willing to help the community with that. Although as it is SEL and WSU Collaboration Week, I think we would be remiss to not talk about how SEL partners with WSU.
I'll let Dave start this one.
Well, it's ever since I started at SEL, we've had a great collaboration with WSU. I remember I've probably been back at SEL for a year, and I was coming back at 9 o'clock on Monday, Wednesdays, and Fridays to take a power systems class. I was a hardware engineer, not a power systems engineer, so that was one way I got to, you guys just let me show up and audit the class. It was really, really wonderful. That was my first experience coming back from WSU and being part of SEL. And from there, we've, as Ed pointed out, we've got, 240 intern positions going on right now. That affects many of the students here, certainly at SEL. Noel is here, and she's our Schweitzer engineering chair. So we've endowed that to the school, and I have an engineering bias because that's the school I went to. But this goes on in the finance and many other colleges within the university. We support senior design projects every year. We'll fund special projects. You know, if one of the professors has a great idea, hey, let's go explore this, and you know, maybe something will come of it, maybe something won't, right? But again, we've learned something by investing in WSU and having our folks participate in the research activities.
Oh, we've done so many things that, you know, like when I came in was a sort of a program in entrepreneurship that Professor Olson used to do. I don't know if that's still going on.
That's me. I do that now.
Well, thanks for doing it. I hope we're still a part of it. And
Bob Olson is my mentor, so I make sure to keep the ball rolling.
well, good. Say hello to Bob for us. And we've also consulted with Bob on several occasions involving things related to electromagnetics. And I know our son Eddie, who's a mechanical engineering graduate from Washington State University, he has a nice relationship with the ME faculty, and not only here but at some other of WSU's campuses. So everywhere you turn around, you know, in terms of contributions. Well, my wife and I got really excited about the WSU Medical School, and then as from its inception, that I knew Elson Floyd quite well, and this was such a tremendous vision of Dr. Floyd, and it's sad that he can't see, or else we can't see him see anyway. He can't see the tremendous success of this after his vision, and then passed away, and here it is, it's up and running, and we've had so much pleasure out of supporting that, and even one of our nieces is a student there now, and we're happy about that. So there's all these things that go on, time and, you know, back and forth between WSU and SEL. It's hand in hand, just truly collaborating in every way imaginable. And we're really grateful. I don't, you know, it's hard to see here because of where's Noel?
Right
there you are. Hi. Thank you for thinking of this WSU SEL Collaboration Week. We really, really appreciate it. We have a ball working with WSU.
So with all the things that SEL collaborates on with WSU, why is it so important to do these collaborations? You touched on it a little bit, but can you expand on that?
It's kind of like the diversity thing. Why would we draw some kind of a line, right, kind of like that, right over on Stadium Way or something, to keep us apart? it's a tremendous gift, you know, where community and collaboration all come together. It's natural. It's a hand and glove kind of a thing. Am I answering your question? I can tell.
No, you did. You answered my question.
And so a large part of the collaboration between our two institutions, if you both alluded to, is the large number of WSU alumni that come to work for SEL. So why do you think so many graduates come to work for you?
Well, I think it's one is because we're a great company. Who wouldn't want to work for us? And two, here's the thing. How many people from the West Side? Well, there's probably a bunch of people. And I love the West Side. I grew up on the West Side. But my first job out of WSU was I worked on the East Coast for a defense contractor building submarines. Really, really fun job. But my wife and I decided, hey, it's time to have kids. Let's try to get back to the West Coast. And I was thinking, I'm gonna have to be working out of Seattle. Those are the only jobs available really for an electrical engineer. And I remember this is when you still read technical journals and newspapers, and it was called EE Times, and there was an advertisement for this company called Schweitzer Engineering Laboratories in Pullman, Washington. My eyes sparked up. I loved going to school here in Pullman. My parents were raised in Moscow, so I had just a love for the area. And I said, I remember this guy came in and gave an IEEE talk one time. I think his name was Dr. Schweitzer. I'm sure he talked about something about power engineering or something like that. But I applied that day. I was fortunate enough to come and interview. The interview was horrible. It was the worst thing I've ever done. I was so tired from it because they're just asking all kinds of questions. Fortunately, I must have done something right because I got offered the job that night, and I was able to come back to the Palouse, and all three of my children were born here. This is such a fabulous community. WSU is, it's a Pac-12 school in the middle of, on the east side of the state, so it's not like downtown Seattle or, Southern California. What a unique opportunity we have here to raise our families in, a tier 1 college community. I can't think of a better place to come back and work.
And you just look out the window. I love the Cub ballroom here. Even with the shades drawn because it's so beautiful and sunny out, that the beautiful Palouse horizon out there. Who wouldn't want to live here? It's just.
And Zocalo too, right out there. So.
Yeah, there it is. Yeah, Z2. Yeah, it's just a wonderful opportunity. And gosh, it might be a real cool thing for you to consider, internships with us, career opportunities, becoming employee owners like you did, and you hit the ground running with the internship under your belt already, and then you get to live here in this, beautiful, pristine, natural environment. You know what? You live in Pullman, it doesn't matter how many cylinders your car has because you won't use it. Shoot, I live a half a mile from work. And it's been such a blessing to be able to, when our kids were little, to be able to even go home for lunch or go over to the school and then come back to work. It's just a real, in so many ways, idyllic life.
So you get to work or live in a great community and work on some really, really cool projects and problems, right? We are a global company. As Ed pointed out, we just came out with this new traveling way. Really, nobody can detect a fault faster than this particular device, or our cybersecurity products. I mean, really, really cool problems that are making electric power safer, more reliable, more economical around the world, right here in Pullman, Washington.
So what kind of future are you looking to work toward with WSU? Because you collaborate with them a lot. Is there anything that you're looking to work toward?
I think I talked earlier about all the distractions in life. So whether we're at work or at SEL or here in the university, that there's distractions. And we really have to single out what's important. And one of the most important things about a university is it gives students their very best shot at learning the fundamentals, the things that don't rust that you'll learn. I'm not talking about, there's some fun courses where you learn how some particular technology of the day works. Like, I don't know, you take a computer science course and you learn about internet protocol. Well, who really thinks that the internet protocol is going to stay static? Something is going to change about that. And in the university environment, that's what it's all about. It's about looking into the future. It's about trying to envision things that haven't been seen or foreseen. And that's important for the university and its students, and that's also really important to Dave and me and 5,300 other employee owners, is that we go back to first principles all the time, like F equals MA, and you can't push on a rope, and all kinds of other stuff, that the things that don't rust. And by that I mean the technology. We're talking about the mathematics and the physics and the chemistry and the properties of materials and all the things that are the rock solid underpinnings. How do you think that the guys at Bell Labs came up with a transistor? That's what they were doing. They were doing basic physics. That's so cool. And the closer we get to nature, the more likely we are to invent something that's really cool, a real breakthrough. Another interesting thing that universities, WSU, University of Idaho, Purdue originally, but all the universities offer opportunities for students and faculty to bridge gaps. So you start to think about, you look at the buildings, and in a way you could think about that they look like castles. Here's the physics castle, the chemistry castle. They're sort of siloed in tradition. And guess what? Thank goodness that we don't think and operate that way anymore, that the physicists teaming up with chemists, teaming up with bioengineers, and with electrical engineers and mechanical engineers are inventing the future. And so this area of collaboration, there's the word again, within a university is just too cool. And out of this sort of thinking will come another company, hopefully here on the Palouse, doing something completely different that none of us in this room all by one's self might envisage alone. But we'll do it together. We'll do it with you at WSU.
Well, thank you for answering our questions today. Now, if the audience would like to ask some questions, we have some microphones up front, and if you are joining us online, you can type your questions in the chat, and if we have time, we will get to those. Does anyone have any questions?
Well, first of all, thank you for your attitude towards failure. I was an intern with SEL last summer, and I fried several $1,000s worth of circuit components. So I'm glad that people
How much?
have that attitude.
We'll send you a bill. Oh, I'm only kidding.
And second of all, I was just wondering if you could talk a little bit about how you have your world-class manufacturing ideals and how that relates, both to manufacturing, but then also to pretty much anything else you do as a company. And I guess that's to either one of you.
You, B. Has anybody read the book World Class Manufacturing? a handful of people. Here's the, I can summarize it, at least the way I think of it is, remove weight, right? How do you make things as short and as quick as possible? And if you think about it from that perspective, that really drives efficiency. How many steps can you take out of a particular process? All of a sudden you wake up one day and something that used to take you 2 steps now takes you 20 steps, or you build a whole bunch of stuff partly and you stick it on a shelf and then it waits for the next person to put on the next parts or something like that. So this idea of being as efficient as you can and removing this waiting or this queuing is really I think the driver behind world-class manufacturing. I don't know, Ed, what are your thoughts on WCM?
Well, the whole idea, the way I like to look at it is make in a day what you use in a day. And if you think about it the way you like to cook dinner, who here would ever think about getting out a big pot and peeling, I don't know, 30 potatoes, cooking them, making a big, huge pot of mashed potatoes, and then enjoying that for the next 30 days? I mean, like cold mashed potatoes are pretty, they're not very interesting. And yeah, you can make potato pancakes, but you get the idea. That's making a big batch. Making a day what you use in a day, it's fresh, you learn from it. And guess what, if you screw up that whole batch of potatoes, you're gonna dread dinner every day. And you make it a day and you learn from it and you improve it, and the spirit of continuous improvement goes on like that. Now, an interesting thing about world-class manufacturing is another part of it is the supply chain part of it. Well, many businesses, go ahead.
I was just going to say, world-class manufacturing turned into just-in-time manufacturing, and I think that's where you're going to head with this thing.
Yeah, that's where I'm going.
Yeah.
Because just-in-time means deliver it late. So here's the idea, that make it a day what you use in a day, and whatever, if there's the 4 of us making some kind of a product, and as Dave said, we want to make sure that we minimize weight states, so you don't want stuff stacking up in between us and so forth. So flow. And we applied these kind of principles to get those shot clinics running, as we talked about earlier this afternoon. So make it a day what you use it. So then what about on the supply side of it? There's companies that have gotten the supply side so finely tuned, they were getting deliveries twice a day from some of their suppliers. So that works good until it rains or snows or there's COVID or an earthquake, or I was reading about an energy crisis in 1917, 1918. My dad would have been 3 years old then in Chicago. And everybody heated with coal. Edison and Insull were generating electric power with coal. There wasn't a lot of lights at that time. And they had a hell of a bad winter. And then the coal wagons couldn't get through to people's houses. People were miserable. Well, they didn't have inventory. Most people don't have enough places to store the coal. And Insull and the Commonwealth Edison Company opened up the gates to their coal piles at their generating stations, so people could go get buckets of coal for their heating and cooking. So inventory of raw materials is your friend, especially when the parts come from all over the world. So we have this thing worked out so well that we have some products that we ship from stock and some that we essentially configure to order, and others that we build to order. But really, at the end of the day, the delivery time for a customer is just a day or two. And it's something that gives us a tremendous advantage. Think about it right now with our friends in Louisiana, Mississippi, and elsewhere affected by this powerful hurricane. There's still people without power. And we already knew what happened there. We talked to Entergy, and of course we could see how many customers were out. We knew what they were buying before. So we started building product with no orders. We anticipated what they're going to be picking up the phone and ordering from us, and right now we're just starting to get orders, and we're able to do that, deliver. We could deliver yesterday, so it's worked out real well for us because we had the parts on the front end of it.
All right, well, I think we have time for one more short question.
I also say thank you for being here today. It's been wonderful to hear you guys. Given your unique and strong strengths in both cybersecurity and power systems, what opportunities do you see for SEL in addressing the power consumption challenges for cryptocurrency, Bitcoin, et cetera?
Man, let me add that question. Cryptocurrency to me is counterfeit money. So, I'm certainly no expert on it, but I've read a lot of Milton Friedman's books over the year. If you want, one of my favorites, I just reread it, is called Money Mischief, one of his last books. And I read that back to back with a book about modern monetary theory, which is a bunch of bunk. So the cryptocurrency, look at what El Salvador did. They adopted it as their national currency, and the main reason I believe that they did that was to distance themselves from the U.S. dollar. It was political. It wasn't financial or anything. So you're right that a lot of megawatt hours are being consumed. It's silly to say that they're using computers to mine something. There's no shovel going into the ground. Hey, if you want to do something useful, go put a shovel in the ground and find some rare earths that are so important to the motors and semiconductors and photovoltaics. That energy would be put to a lot better use for humankind in that way. That said, that there are a customer of electric power, and that's my opinion. They're purchasing the power, I guess, legally, and I guess in some way we're a part of that. We're certainly in no position, and nor would I ever argue to turn it off. But I do believe that the cryptocurrencies have a tremendous drawback of being another money supply that is not under any sort of management by the Federal Reserve or its cousins in other countries.
All right, well, thank you for that answer, and that wraps up the Q&A portion today. We want to thank Ed and Dave for being here and answering our questions, and we also want to thank all of you in the audience for being here today. If you are here in person, we will be holding a reception right after this, and we hope you'll stick around.